Hello and welcome back to my channel. Today I will show you my approach to building the Cant of Aston Martin 177 based on the tutorials from Recepie. So let's get started. In the previous video I already built this side barrel. Now what I need is the outer contour of the DLO, and then I will be building off that the edges here that run through the Cant rail, and which will allow me to build this piece of the car. So let's start with the A-pillar. In a certain view, the A-pillar is always, or most of the time, the dead straight line. So we will try to get that in. For that, using these cross sections, I will snap here a curve, and then that curve will be the base for the rest of the curves on the Cant rail. So I'll take a degree 1 curve and I will bring it in somewhere between this point and this point. And when we look at the sections here, I will be aiming to snap it to this sharp edge here, because that is my assumption where the inner line of the DLO would be happening. So where the body color to the DLO trim boundary would be. So let's bring one in here. Point 1 and second point, third point, and the fourth one. This gives us, in this view, a line which is following that. But you see, it's a line which is degree 1 with 3 segments on it. So then what I'm going to do is I will turn that curve into a degree 3 curve with no spans, so one span only. Well, let me get that in there. Okay, so degree 3, 1 span, perfect. So now we have that curve there. And what I will do, I'll pick this view to see where this curve is looking like it's sitting on one plane. That means that if we bring a degree 1 curve to both of its ends and we rotate it, it will look like it's on one plane. Perfect. So now let's bring in the side barrel. I will offset this to set around 8mm off of the original barrel to give me constant distance between the Cant rail and the glass. This constant distance will be needed because normally the DLO trim around here is an extrusion. So that means it will have a constant distance to the glass and to the sheet metal that makes the Cant rail or whatever material is used for the exterior. So let's offset that 8mm. And this is the view where it looks more or less straight. So in this view, I will project a straight line onto that 8mm offset. And this will give us this curve. So now let's see where we are. It looks like the 8mm offset for this model is a bit too much, so we can reduce that to, let's say, 7mm, and we start seeing that the mesh data is poking through. So let's say 6.5. Yes. So we can see that the cant rail on the upper side here is sitting at that 7mm offset, more or less. So I will stick with that for this purpose here. So now we can see in the side view that the curve that we've snapped here, onto the model, and the curve that we projected onto the 7mm offset, they are looking very different. So what I will be doing, we'll take that curve and also project it in the side view onto this 8mm offset. And now we see where we are. As you can notice, in the view where that curve is looking straight, it gives us a very round curve in the side view, while the curve that we've projected in the side view, it's very, very hollow compared to the other one. It looks like it's bulging out. So what I will be doing is taking the surface and fit a curve to it, and then I will put a degree 1 curve, and I will search for that view where these curves seem to match, being on one plane, and I will project that curve, second straight curve, onto that offset surface. This way, I will get a third curved surface, which allows me to see how far off these are. You see, these are very round in the side view. This is flatter, similar to the model. If we're trying to get closer to the model, what we need to do is change the view in which we projected that curve. So slide this one away, slide this one away as well. So for the same area, we have two curved surfaces. What I will be doing is I will rotate the model in such a way that that straight line is sitting somewhere in between the two, which will mean that I will find a compromise between the round and the flat one, and that is the curve I'm going to go with. That means that in this view, the way we are sitting now, we will have that straight line. If we want to save that view, we can go here into the cube area, or we can go into the variant lister, and we can capture a variant here. So let's capture here a variant. And this means that we will be saving the view for the 8 mm. So I'll call that 8 projection. Using this variant, I can always return to this view. So let's close the variant lister. And now we have side view projection, and we have the one that is sitting straight based on that variant. this is the one I will go with. It is a good compromise, and I will say it's safe to use. Now, what I will do, I will fit curve that, use a degree 3. It's a pretty simple curve to work with. And then what I will be doing, I'll bring back my model. And update that offset. And let's see, we have here the fit curve. Looks pretty nice, not too round but not flat. I'll put this straight curve into my curve layer, and I will extend this curve here to see how much it follows the model. And based on that curve, I will generate the second one here to run along with the Cant rail. And this way, I will generate this boundary between body color and the DLO trim. So my aim here is to capture a curve which runs all along with the Cant rail up to this trim, lower DLO trim area. So for that, I will snap a point here. And then I'll get that in there. Let's make this a degree 3 curve. And I will use the stretch tool and one handle. And I will snap that handle to one of these peaks here. That seems good enough. Now, let's turn that into degree 5. And I will again use the stretch tool and one more handle. So now we have 2 handles, and I'll slide one here to get me close to these sections, and I will slide the other one back here again to be close to the section area, and I will snap it to that peak. Okay, we are getting there. So now we could build this using a theory like this, which means that in this area we will be above the model, or what we can do is also curvature align this curve to this other one and then tweak this curve. So we have a construction based only on 2 curves, which would be enough given the fact that this is a coupe. It has a nice flowing Cant rail. If you look at it, the accent isn't as strong as you would have within 2 defined lines and blend between them. So let's go ahead and do that. So I will extend this further, and then I will curvature align this curve to this other one. Now see, it lifted everything off of that model. So what I could do here is work with the curvature of this curve here. So we know that this curve is sitting on one plane. So with a CV move tool and in the normal direction, bring it down this brings that curve inside of the mesh model. So what I will do is come back out and adjust this curve here. So I'll bring the tangent point a little bit in, this point in as well. And what I will do here, you can see that this is not sitting on the edge anymore, not even in the side view, so I can add here a bit of crown, which will help us in that manner. And we see that the model is also twisting a little bit, so that shouldn't be such a big problem. Let's slide these CVs more curve forward to bring that accent up. This one up as well. Now we can slide these down. What I want is this curve is resembling as much as it can to the mesh here. One way of checking that is we could build a draft with history on it in the y direction, and then we see how that adjusts to it. So we see that here we are sitting below. So what we could do is the final point there, we lift it up a little bit, and then we start adjusting these CVs a little bit. So push this one up. A little bit more. Then push this that direction. We have to take care of the CV layout. Nice and clean. So either accelerating or going constant. Accelerating would mean that the distance between the CVs is getting shorter and shorter from the back to the front. So now this will do it. This needs to move more forward. This one might as well go a little bit up, and this one could accelerate a little bit, meaning that we slide it more upward. So let's see what this does. This could come down a little bit. This is looking pretty good. So this looks like it. Now let's delete the history on that. Let's get rid of that. I'm gonna extend this back to that one there. Now let's take the curves. What I will do, I'll just move them out and make them flatter. And I will project them onto this offset that has curves. So in the side view projection, so in y direction as curves, match original, and we'll choose the two curves. So let's go to the variant lister. We go into the projection area, and we will see that our curves are lower curve is not straight anymore. You see, it's ething. That means that we need a bit more crown on this area, so it needs a bit more curvature there. So we can lift that CV a little bit. And this can be lowered a little bit. You can also turn up the degree on this curve. I use the rebuild curve. And now let's realign curves that we projected there. So I will go back into the variant list and go into that way that we projected it, and I will tweak that curve a little bit. We see if we slightly tilt the view in a different direction, we are getting there. So it's always a bit of a back and forth on this topic here. So I will be adjusting the curve that originated everything. So in certain view, I'm getting a straight line, and there we go. We have that. So we don't need that straight curve anymore. And now what we can do is we can take those two curves and we can copy paste them. Actually, what we will do, we will take them, and then by making the model visible, we can offset these two curves till it looks like we're getting to the outer edge of the Cant trail. Now we can take those curves that we've just offset, shade the model, and now we could move these curves in the y direction till we match up that chamfer there. So now we have the first set of curves there, that area. We see that we are deviating from the edge there. So let's go ahead and adjust that curve. So let's align this curve to this one. Let's see where that changes direction. That seems to suit pretty nicely. Let's go back into that variant. So the funny thing about offsetting sometimes these curves is that depending on how the math is working, even though you had a clean curve, it might get a little bit distorted. So what I will do, I will squeeze the view here. the S in the curve seems to overlap as good as it can with this straight curve. Now with the CV move tool in the view, we will be adjusting the CVs till they sit as good as they can on that straight line. This means that in this particular view, the curve will be looking straight. Okay, now I've done that. Let's see where we are. So let's go back to the normal view. See where we are there. We could throw in some basic skins here to be able to get some sections on these surfaces to see how these surfaces are working compared to the scan. I'll go into the cross-section editor, turn on X sections. Here on this line, I will go with what the offset is giving me, because in here you see we are getting a pretty good match. So in the side view, you see we are off. But that means that I need to adjust this curve here a little bit. Maybe bring down the tangent, curvature area. And you see we are getting closer to the model. As I just said, I'm happy to live with this deviation here because my focus here in building this area is to build the A-pillar closer to what you need to be able to produce a car like this. That means correct distances to the side barrel, and that would allow the feasibility of that area. So now let's adjust that curve there, because it still deviate quite a lot from what the original model was doing. So for that, I'll pull these points in, bring them to so in top view, and push them in the Y direction until they seem to follow that edge there. This one will come out. Here we bring in these. And now, in the side view, slide away the CVs on these two curves so we don't move them by mistake. And let's adjust that curve. So in the side view, we'll lift these points up till they come out of the model, and till they seem to emulate what the Cant wheel is doing in that area. For this, using the cross sections is pretty good because you get to see how your surfaces are doing. Let's get this. There we go. With the half theory there. This comes up and out. And we are getting there. Now, the next step would be to elongate that curve, so to extend it till it gets to that point there. One way of doing that would be to use the extend tool. We'll turn on the extend function on that curve, and I will extend the projection curve first. So I know it reaches to roughly this area here, and we'll extend this curve, and we see what it does. So let's correct it. Realign it here to this curve. The CV layout of that will help. So what I'm trying to get is a nice flow from this curve to this, with this edge to the other one. So I'll pull this back in here, this one back. So those CV rows are sitting pretty nice. Now this CV on the projected curve needs to move up and out. The end needs to move out here, up. So that one needs to move spin down. And we also need to adjust the projection curve, because it is pretty uneven now. Let's get that back there. Realign it to this one. Let's lift this point up a little bit. And we see that here we're deviating from the model, meaning that the curve that we've used here for the glass barrel, we could accelerate the end part of it a little bit. So let's pull up the curve and let's move this CV in the normal direction in, and you see now that skin is turning inward. Here we're coming out of it. So let's see if that is good enough for this purpose. Let's make this default again. And let's adjust the curves, the CVs on that curve there. So we get that clean CV layout back. Switching between the CVs by pressing Control and the arrows. So that is helping me move along there. Lift this up a little bit. So that's pretty good. Let's bring it up a little bit. Ever so slightly. This goes in. Look at that. That should do it. So now let's work with this curve. So we are way off the model here. So let's look at this one. Pretty deep in the model. So let's move that up and then in the y direction. And let's see what this gives us. Now here, higher model for this area. Let's shade the model again. Now let's try to clean up that curve. You see we're way off. So we bring it this way, here we bring it back in the y direction. also back in the Y direction. The intention is here, seen from the back, to get pretty clean curve, and that it's not missing. And then we will have to see how we make it look nice. So this needs to move up and out of the model. Now this moves down and down again. So we see that on this curve we would need a couple of more CVs. So let's go ahead and do that. So this is a degree 5. We'll make it a degree 7 and work with that. So we need to flatten the curve here, because you see we are too round. Okay, so let's keep on going with that. Here we need to bring this curve down. So what will happen is we have a curve that's running into the mob here, and we'll have to get another one to bring us all the way to the spoiler edge. So it seems to work from this view. Let's pull this one in here a little bit, this one here as well, this one up and out. I would like this to run smoothly in that direction without any messing, as little as possible. Okay, now we have this boundary here, we have that inner line there. What we can do is now we can take those two and we can offset them in this view by a couple of millimeters, so in the side view. So let's do 2 millimeters in the side view, and then we move those curves in the Y direction, because these will build up chamfer here. So skins again. Skins are a great way to control first surfaces that you're doing there, to see how good you're getting there before you commit to building bi-rail and more precise surfaces. So let's see. These seem to work pretty well. And don't worry in this lower area about the curve going into the model, because we will have to blend this area out. And also, another topic that we need to cover there is these lower CVs. They could also move a little bit up because they sit on a plane. So it could help lead into that direction change. And we can also see that the inner line, for the one that we last built, that could do with a bit of twist compared to the other one. You see here on the sections, especially here, it's twisting away a little bit, so that means that in the side view, the A-pillar is ever so slightly opening towards the bottom. And towards the top, you see, doing pretty good. You're on it, a bit off, on again. So for first try, I would say that is good enough. So we have an A-pillar, and we have somewhat of a cant rail. You can still move those curves a little bit inward. And now we have the inner edge there. After that, we can build the rest of the model. So let's see what we're doing here. See that chamfer we had on the A-pillar is gradually becoming wider towards the bottom and builds this inner edge here. So we might as well go ahead and build it that way. So let's hide these surfaces in here. We can align this curve to this one. And then I will set my pivot here. What I will do, I will start scaling the curve till it looks like it's taking the width of that chamfer. So proportional scale on top here, and then I will move it in, move it out and up. And again, in. The reason why I've done that is to keep curvature relationship between this certain curve and this one. So we have a nice flow there, and then we try to get that flow there that the model has by scaling it and thus keeping the character of the line as much as we can. And what I will do, so keep on scaling it to this point, and then at the very end I will start moving the last CV to give me that lead into that transition area there. So there we go. Now we have that. Now we have generated the A-pillar and the cant rail's biggest piece there. The next thing we could do is take these curves that we've used to project it in here and to sketch model in this trim piece here. You could offset that in the side view. So it looks like we're hitting that highlight there. Looks constant, pretty good. what we could do is also open to the bottom a little bit. As we see, it's going to be a big volume here at the end. So we might not need the history on that curve. Push it down a little bit. Now we can project those two curves onto that 8mm offset or 7, whatever we've done. Template that offset. Now we'll build some skins between these curves here. And from these curves, the inner ones, I will make a draft going into the y direction, an angle, say 10 degrees. And then we have our trim, the DLO trim. And now we can intersect our side barrel with the drafts that I've just built and trim away the excess. I've also built the last two curves on the lower end of the belt line so we can get this close contour there. So there we have it. Let's just say shade it in nicely, and that would do it for the A-pillar and the Cant rail. So these curves go onto curve layer. It's important to keep everything in neat order. The template that I've done, the 7mm offset, goes also onto the same curve layer because it's helping me generate the curves. Let's turn on the hardware shader, visualize one, and I've done some basic shaders there. So what I will do, I will assign, let's say, the bodywork, this blue shader. This is already done with this dark shader to emulate the glass. And these, I will shade this bright whitish shader to look like a piece of chrome. And these curves, because they're curves used for projection, we put them on the layer for projection curves. And that's that for today. So in the next lessons, I will try to build the roof and the rear glass and windshield. And piece by piece, I will finish up the greenhouse and move down to the shoulder area, blend the A-pillar, blend to the shoulder in the rear area, and we will keep on going and slowly building some of these more difficult areas on the car. Thank you for watching, and if you've enjoyed this and found this informative, please subscribe and stay tuned. Catch you later.